This is a quite general example, so I'm going to stick with the discussion activity. So when we have a velocity vector, let's say it's at here, and this velocity vector is changing with time. So this is the velocity vector at time equals t. After some time, the velocity vector becomes this one, which is different when it was at time equals t. So let's call this the velocity vector at time equals t plus dt. Then the change of this velocity vector will be this one. And we can separate this change of velocity vector, let's say it's dv, into the component that is in the same direction of the velocity and the component that is perpendicular to it. So this is the component that is parallel to the velocity, and this is the component that is perpendicular to it. We need to let them add up to the change of velocity, so this is the components. We see that these two terms will correspond to these two in the equation above. We are just looking at the change of velocity, so it's just going to be the one that is changing magnitude in the direction along the velocity, and the one that is not in the direction of velocity. And the change of velocity vector dv, not the velocity vector, the unit vector of velocity. So dv head will be a direction that is perpendicular to velocity. So we know that this component is along the velocity vector while this one is perpendicular to it. Now, let's suppose the second term is 0. It means that the acceleration, which is the same as, which is parallel to net force, will be in purely the direction of velocity, because any acceleration perpendicular to velocity will be represented by the second term. There's no way the first term represents any perpendicular direction, because the direction is captured entirely by the unit vector v hat. So the first term can only represent the change of velocity that is parallel to the velocity itself. Therefore, in this case, we know that the net force will be parallel to the velocity direction if the second term is 0. Now, when the force is perpendicular to the object's motion, and then we know that the acceleration, which is parallel to the net force, will also be perpendicular to the directions that will be perpendicular to the object's motion. So in this case, there's no way that we have contribution in first term, because first term is always parallel to the velocity. Therefore, we know that the first term, dv hat dt, dv dt v hat, actually, the first term is always going to be 0, and then we will have a non-zero contribution in the second term. And this second term is going to keep the magnitude of velocity vector constant, because this is just a constant without integration, without differentiating. And the second term will change the direction of velocity. So in this case, when the net force is perpendicular to the velocity, the speed of the object will be constant, but it will change the direction of motion.